Yowzers, folks. The sun is so bright that I've got to wear shades. Now, we look at it in all kinds of different wavelengths. And from the SDO, we've got a lot of iron emission spectra to look at, also helium, carbon, and others. And we're starting out at 171 angstroms. We've got 5 sunspot groups. And they're all in the west, all in the western hemisphere, folks. There is some activity rising in the east, but the main story are massive filaments. So this is a composite image here. This is ionized helium and ionized iron. And you can see this massive filament draped all the way up around the northeastern limb here. And a prominence up here looks like it is in the process of ejecting right now as it moves toward Earth. So great view of this filament here. Some minor diffuse coronal holes here on the eastern equatorial area. They're North Pole oriented last I checked. We'll get to it in a minute. Here are some close-ups of these sunspot groups. They're quite active, and the likelihood of major solar flares is certainly there. So coronal mass ejection warning. And also a solar flare warning, both in effect until further notice. So yeah, great close-up here, just spectacular and compelling imagery from the Solar Dynamics Observatory. Here's another composite. This is 171 and 94 angstroms. Shows you a little bit of different features there associated with those highly active regions. And we see activity at 2 different latitudes once again. You've got these lower latitude sunspots that are closer to the equator and these higher latitude sunspots that are closer to the pole showing up at the same time. Here's a close-up of the northern hemisphere, and you can see that giant filament. It's like 40 Earths in diameter just on this side of the sun, and it continues on to the other side. So we've upgraded the coronal mass ejection watch to a coronal mass ejection warning, and the solar flare warning remains. The 10.7 centimeter radial flux actually came down to 92 here. You can see this very rare crossing of the sunspot number and the radial flux. The radial flux is the black line. The sunspot number is the red line. Here's a space weather enthusiast dashboard. No space weather storms forecasted at the moment, but a coronal mass ejection forecasted by me. Let's take a brief look at seismicity. Here's the year-to-date earthquakes. Here's the past 90 days in earthquakes. That's a bar graph from Volcano Discovery. And no major quakes over the past 24. Antarctica did see a quake there. Also, Kansas saw a 3.1. South Sandwich Island still shaking a little bit there. It looks like things are subsiding a bit. So pretty much a lull in earthquakes here. There's a 5.3 out in the ocean south of Kamchatka, north of Japan. Also a 5.3 in the Solomon Islands there, northeast of Australia. Also a deep quake at a 5.1 magnitude near Japan. Not a lot to report on when it comes to earthquakes. Let's check volcanoes. As we see Suwanosejima having exploded here, produced a 5,000-foot ash plume, and Langila continuing to explode here, I think appearing on the list just yesterday or maybe 2 days ago. 7,000-foot ash plume over New Britain, part of the Papua New Guinea archipelago. Popocatépetl exploding in central Mexico, 21,000-foot ash plume over one of my bucket list volcanoes. Sangay, 20,000-foot ash plume as it explodes. That's located in Ecuador, as is Reventador, 16,000-foot ash plume there. Volcanic ash is being emitted from Sabancaya in Peru as well as it explodes, 24,000-foot ash plume over Peru. Please do not pole vault the caldera. Please do visit our links. You can find them all at smashomash.com. Enhance your wardrobe via the Smash Team's merch. Again, you can find it all at smashomash.com, including links to the Smash Team. And it's spectacular. Yes, it's a replacement for Patreon. If you'd like your Patreon replaced, drop us a line. If you have any sort of a business, you don't need to be a content creator. If you have any sort of business, you'd like a website made, drop us a line. Perhaps we'll do it for you for a price. Here's the GOES magnetometer over the past 3 days. And we're seeing a little bit of spikiness here, not very smooth GOES magnetometer readings from the GOES 16 and 17. Although Earth does still remain in a North Pole current sheet, I'm pretty sure. Here's a view of that, the top view ecliptic plane field plot. It's part of the Gong 2 data, folks, which is the National Sunspot Observatory. Based on a lot of magnetometer data from Earth, as well as from Stereo A and Stereo B's magnetometers. That's Lagrange point 5 there, Stereo A. That's Lagrange point 4, Stereo B. And Earth will remain in a North Pole current sheet for the foreseeable future. Here's another view of the same plot, basically, from the line of sight perspective. Also showing you the solar magnetogram. And we're going to drop down to 4 named sunspot groups, I believe. Maybe even 3 throughout the day today. We'll get to that in a minute when we look at the solar flare monitor. And here's our line of sight coronal hole plot showing you this North Pole coronal hole rotating through. It's that green area, reaching down just across the equator there, looking very diffuse, not like it will provide a significant solar wind, particularly. Here's 193 angstroms. This is ionized iron, and this is one of the best wavelengths to view coronal holes. You can see a bit of a diffuse area here, which looks like a coronal hole. Also around here, south of this filament. So that coronal hole is kind of right at the I guess you'd say southwestern point. That filament ends right about there. And again, we see part of that looking like it's ejecting now. So here's the GOES 16 SUVI imagery, and it looks exactly like a dragon spitting fire right over here. I mean, just classic imagery. We also caught a quite compelling coronal mass ejection that looks like a giant flux tube coming out of the South Pole yesterday. Just insane image. Insane imagery, period, showing up here with the recent uptick in sunspots and radio flux and everything else, filaments. And we're expecting a continued increase in coronal holes here over the next 2 months. We've been calling that for a couple weeks now, and we do see a slight increase. Look for a big increase in coronal holes. That looks like it's about to become a coronal mass ejection. We'll probably do another video today, maybe even 2, as we've got so much imagery of the sun that we want to share it with all of our viewers. We've been doing lengthy streams, and if you look at yesterday's stream on Twitch, the earlier one that was 3 hours and 36 minutes long has an insane coronal mass ejection coming out of the southern hemisphere. So if you look in the south here, I'm going to zoom in. Oh, I can't really zoom in because it's a video. All right, so if you look down here, check that out. Just an insane CME down there. Looking like a giant flux tube, like a tube that's also a spiral, if that makes any sense. Anyway, lots more streams coming to Twitch with all this activity kicking off. So here it looks like we're actually at 3 sunspot groups here. So, but the likelihood of major solar flares is still certainly in effect. Coronal mass ejection warning. It looks like there's one happening now. And whether it will be Earth facing or not, if I had to guess now, I'd say it's not going to be Earth facing, folks. I'd say it's going to miss to the west and north. But that's just a preliminary guess. We have no data on trajectory yet. So coronal mass ejection warning, solar flare warning, major sunspots approaching the limb. Likelihood of M-class flares, in my opinion, very high. Speaking of flares, we ain't seen no big flares recently. There's been a lull in activity. It could be the calm before the storm. I'd say it is, if I had to guess. No spikes in the proton flux of note. No coronal mass ejections headed our way at the moment, at least not major ones, and certainly no relativistic protons striking the magnetosphere. So here's the real-time solar wind data. Pretty uneventful here over the past 24 hours. Solar wind speed currently around 340 kilometers per second. Solar wind density around 6 protons per cubic centimeter. BZ has dipped into the negative territory. So the total field is 7 and the BZ is -5. South pole oriented magnetism. Here's the KP index, a measurement of geomagnetism. Keep in mind these measurements are made at Lagrangian point 1. These measurements are made by ground-based magnetometers. So here's global geomagnetism, KP of 2. And that is an average of global geomagnetism. And we're going to look at all 3 geospace magnetosphere movies today. So here's the velocity. And what you're looking at here, the reason there's high velocity back here, folks, is because behind the Earth, there is a lower density region where protons get reintegrated into the exterior solar wind. The portion of the solar wind outside the magnetosphere is at a completely different speed and everything regime to the portion inside the magnetosphere. And those green areas, that's high velocity accelerations of particles that are deciding to not enter the magnetosphere and to instead get back into the overall solar wind regime. Next, the density, and I've shrunk that down one size. This is showing density, dark blue for high density, white for low density. And we do see some shifts happening here. I'm going to let that play through so we don't have to edit the video. We don't edit the videos. Typically, folks, we tend to keep them raw Wu-Tang Clan style. Shout out to the Wu-Tang Clan. Yes, the RZA, you should be watching our videos. Cheers. Perhaps we'll feature some of your tracks sometime or an interview. Anyway, there's 4 hours of density data as interpolated by the Space Weather Modeling Framework, which is a complex series of magnetohydrodynamic calculations based on a lot of data sets. Things like the electron flux, solar wind fields, etc. Last but not least, we're showing pressure here. This is in nanopascals. And again, this is modeled by the Space Weather Modeling Framework. It's 4 hours of data courtesy University of Michigan. And we show it daily on the videos. Look for streams of this coming in the future when coronal mass ejection strikes, when coronal mass ejection strikes and coronal hole wind streams are expected to be striking. And we do see some variations kicking in here. Next, looking at geospace delta B, these are changes to Earth's own B field. Let me get a better zoom on that. Set it to 80%. So we do have a possibility of some auroras here, mainly because of the shift in the BTBZ. Fairly strong total field with a strong BZ component. So we do see some auroras there over North America. Here's the global map for magnetic perturbations. Let's bring that back. So now you're looking at geospace delta B. This is changes in Earth's B field, the field that goes through the magnet. In this case, the magnet being Earth. And we're going to skip the polar view today, and we're going to show you the auroral forecast. So if you all of these Space Weather Prediction Center pages have a series of links at the bottom. One of those links is to the auroral forecast. So there's the auroral forecast for you. A little bit of magnetism causing a little bit of an uptick in geomagnetism. We should see a little increase here right at the end of the video. This is showing more than 4 hours, obviously, folks. And there you can see a little bit of an uptick. Aurora's almost making it to Tasmania, and shout out to our Tasmanian viewers. Thanks for checking out the Red Bubble Shop. So here is the diagram that we show daily of the solar system. That's where stuff is now. We'll advance it 1 week. There's where things will be on the 19th of smAshtember. And happy smAshtember, folks. Here's a star chart I've drawn in the ecliptic and the galactic plane. Galactic plane in blue, ecliptic in yellow. Mine's facing the south. I'm currently facing the south. Our cosmology segment's going to be short. We're not going to pick anything random. We're going to pick something very not random. And just a quick little tutorial here on how to use the Neil Gehrels Swift Observatory. If you've got an object that you want to look up, hit Control F and type in the object. So for example, let's say you want to look up Sagittarius A star, that's SGR space A. And you'll find the core of the Milky Way galaxy. We're not looking that up though, we're looking up Cygnus X-3. So Cygnus X-3 is Sig space X-3, the high mass X-ray binary. It's also the tail of the Swan Deneb and the brightest intrinsic object visible from our solar system. And you can see it's actually in a state of extremely quiescent activity here. These are its hard X-rays, and you can see it's very, very quiescent right now. It's as quiet as it gets. That's the historic graph in the upper right. That's 16 years of activity. This is 30 days of activity, and you can see it's at 0.00, which is about as low as we see it from its baseline. It's nowhere near its baseline. And we want to see this thing studied in radio in between quiescent and X-ray loud states. Hopefully somebody tunes in and tells their favorite radio astronomer. Let's move a little bit closer to Earth here. Check out the spiral aurora on the apod.nasa.gov site. The astronomy picture of the day is a spiral aurora. You're basically looking directly up a flux tube, interestingly enough. So the reason the aurora appears spiral is because it's propagating into the atmosphere directly above head. And that's at an incredibly high altitude. That's at the bridge between space and Earth. And yeah, that one's so bright that the sun is in the imagery. Great auroras there over Iceland. It's the astronomy picture of the day. Abso-smurfly spectacular. You can also see different color striations here coinciding with different chemicals being excited by the incoming particles. Anyway, that's today's cosmology segment. Check our other cosmology segments on our playlists. We've got hundreds of cosmology segments. YouTube.com/smashomash/playlists. Lots more stuff to do. Let's blast through more data. We see some minor charging hazards here over southern Mexico and moving into the Central Pacific Ocean at the moment. Although we don't see high levels of electron flux, we do see some oddly high bands. Basically some electrons out near space. Anyway, that's a one-year chart of the relativistic electrons from Solon.info. Here's a 3-day chart, and we didn't make it anywhere near warning levels or anything like that yesterday. We've just got some chaos in the locations of electrons. Here's a forecast. The forecast is for an uptick coming in the next couple of days here. Not a real high forecast there. Here's a diagram of what's going on up there in terms of Van Allen belts. Yes, the dual radiation belts that surround the planet. Most of the electrons are down here, but some of them are up here. And let's take a look at all of them on the total electron content forecast. Let me shrink it down one size there to 90%. And we're going to see some very high levels of electron flux here once again over Southeast Asia, making for some serious GPS errors. Also over the Indian Ocean. Some major GPS errors there. Showed by those orange areas. And for you new viewers, mostly GPS errors occur around the equator at noon. If you're around the equator at noontime, expect your GPS not to work well. Here's a diagram of the atmosphere, including temperatures of the thermosphere and penetration of electromagnetic radiation and locations of layers of the ionosphere and molecular density therein. Here's your ionogram map. This one's courtesy of Australia Government Bureau of Meteorology. Shout out to our Australian viewers. We hope you become free at some point. So we see some anomalies here. That moment there at 10:15 Universal Time looking pretty normal. Some low frequency anomalies there on the sun side and some high frequency anomalies on the dark side. So here is the anomaly map. We see some low frequency anomalies here over the Atlantic Ocean. Those are shown in red, and this map is showing you anomaly in megahertz from the 30-day median. So some low-frequency anomalies around the North Pole and some high-frequency anomalies around the South Pole. Here's the latest image there, 10:15. Things looking not that out of the ordinary there at 10:15. Moving on at breakneck speeds to look at the bonus features of El Teide, Spain's ground-based solar observatory. Here it is. Massive filament up here. Could be in the process of releasing now, but it doesn't look like it. It looks like it's still stable. This filament up here looks like it may have released as we recorded the video. It looks like a coronal mass ejection going on as we speak. That's why we upgraded it to a coronal mass ejection warning. Here's your latest refresh of the solar intensity gram, and it looks like we're going to have to make another video today, so make sure you stay tuned into the YouTube channel, youtube.com/smAsho. We'll probably make a supplemental video today, and probably a sun video as well. So here's the colorized magnetogram. These sunspots are still more than capable of producing major flares, including M and X class flares. So here's the 304 angstroms imagery. Just absolutely spectacular. So that's your full disk view. And here are some close-ups of some major sunspots at different altitudes. I mean latitudes. You've got these higher latitude and lower latitude spots showing up here at the same time. I find it interesting. What say you? That's 94 and 171 angstroms. And we'll close out today's video on this close-up. On this close-up, which is 1700 angstroms. And I believe there is some growth in the leading group here. So the trailing group looks like it's shrunk a little bit. The leading group looks like it's grown a little bit. Again, solar flare warning, coronal mass ejection warning in place. Thanks for tuning in. Please support the channel. Visit the links. Become a member of the SMASH team. And may that solar wind be at your back.